to integrate powerful geospatial insights from dozens of available Google Maps APIs into your data pipelines, but you're stuck and unsure where to start? Today's video will highlight how we can easily set up this sort of pipeline. Let's quickly draft a diagram of our grand plan, then dive straight into the action. We'll be using Google Maps via Google Cloud, all thanks to APIs. Using PySpark on serverless Google Cloud Dataproc will help us easily create the pipelines. We're going to roll up our sleeves, build an example PySpark pipeline, run it in Dataproc, and use the Google Maps API. For the source data, we'll find a public dataset on BigQuery. Enough with the introduction, let's get to the fun part. First up, we'll take a trip to BigQuery and set up an example dataset as the foundation for our pipeline. For the BigQuery public dataset, let's pick an interesting dataset that highlights tree locations in New York City. In that dataset, we've got a few tables at our disposal. Let's go with the latest 2015 data. In the table, there's some juicy location-based info that will benefit from our Google Maps API enrichment. Next up in our mission, let's fire up the Google Maps system and configure a shiny new API key. Just to be cautious, we'll add an API key limitation focusing on the address validation API. This means our key will be exclusively used for that. The validation API will be useful for getting geospatial metadata for our tree addresses. Before we integrate this API into a pipeline, we're going to put it to the test with the curl call. All we need is a templated command from the Google Cloud documentation and our API key. The response comes back nicely, and we have quite a bit of valuable geospatial data here. Ready for some PySpark? Let's draft the pipeline specification together in the Cloud Shell editor. The objective? To check whether our trees are on a business or residential property, then total up the results. We'll adapt this code to our cloud context, and we'll first set BigQuery as the read format. We'll also opt our table as an option in the read operation. We'll need the whole path, so we're going to grab the project and dataset as well as the table itself. Note that this creates a data frame reader rather than a data frame itself. We'll finish the load and trim down the records later in the video. We don't want to run API calls for the entire 500,000 table records. That would quickly hit massive costs and quota limits. Seriously, be careful about costs, as running over too many records or doing looping in unexpected ways could mean a huge GCP bill spike. Anyway, next on our list, we're defining a user-defined function for our API call. To keep things simple, our API token will be hard-coded into our script. Final step, figuring out if the address is a business or not, saving that as an is business column, and then aggregating. Then we'll finally print out the fascinating results. One quick sidebar, keep an eye on Google Maps' terms of service, especially regarding saving or caching the Google Maps API data. We are, of course, not providing legal advice, just noting that the terms of service have some relevance for how you can use Google Maps API responses. Next up, we need to make sure our network's got a subnet that allows for private Google access. Let's check our subnets and turn on private access for, let's say, US Central 1. Once that subnet updates, we'll set up a Google Cloud Storage bucket for our pipeline specification. We should be able to move our specification into that bucket using the Cloud Shell. And there it is. As alluded to before, we're going to want to trim down our data a little bit before we actually run this pipeline because we don't want to run over 600,000 records through the API. That could get quite expensive. So we're just going to load the data from the reader into a data frame and then apply this limit here to cap our data at 100 records. Let's copy that revised pipeline into our bucket and then continue along. We'll select a PySpark type job and specify our pipeline file and then simply submit. And now we see success, our serverless PySpark job ran, and it looks like most of our addresses for the tree data are residential. We hope that this video was helpful and want to thank you very much for watching. Please enjoy responsibly.